Hello students, welcome to DPCA. Now we are going to discuss the concept of similar triangles or triangles from NCERT, 10th students. Similar, or here we are going to discuss about the chapter name is triangles. The chapter name is triangles. Sixth chapter of NCERT book. In this chapter we are going to discuss mainly a similar concept. What is a similar? We have a two words generally in triangles, similar and congruent. Congruent triangles. Similar means if two triangles are said to be similar, if they are same, if they are same in shape, only shape they are same. They are same in shape only. Congruence means two triangles are same in shape and size. Same in shape and size. Similar means the two triangles only they are same in shape, and congruence means they are same in shape and size. Here in this chapter we are going to discuss about only the concept of the similar triangles. The definition of the two triangles similar definition is if triangle ABC is similar to triangle DEF, that means triangle ABE is similar to triangle DEF. Suppose one I am taking smaller one, another one is big, DEF. So that means angle A is equals to angle D. Now you observe the series A, B, C, D, E, F. That means angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. And in corresponding sides are in proportionate. That means AB by DE is equals to the ratio of AB by DE is equals to the ratio of BC by BC and DE, that is equals to and CA by FD. Sides are in proportion and the angles are equal in two triangles. Let us discuss about the first exercise of the chapter number 6, that is here 6.1. What is this? Fill in the blanks using the correct word given in the brackets. All circles are either congruent or similar. Similar because the circles, when one is smaller and another is big, whatever it may be, they are same. They are same in shape, not in size. The radius of this one is suppose 1. Obviously, this one is more than 1 only, right? So they are same in shape, not in a size. Therefore, we can go for similar. All squares are similar, not congruent, and all dashed triangles are similar. So isosceles triangle is different. So here equilateral triangles are similar. Here equilateral. Why isosceles is not? Because if you find the ratios of corresponding sides, the ratios are not equal, and either equal, you can go for equilateral triangle. With equilateral triangle, we can go for it. So only equilateral triangle. And two polygons of the same number of sides. Okay, here I have a 3 number of sides. Okay, I'll go with the 3 sides. Okay, of similar if their corresponding angles are corresponding angles are equal. The corresponding angles are equal. This is equal, and their corresponding sides are proportionate. Equal and proportional. They are equal and proportional here. Now we can go for this one. Give two different examples of pair of similar figure. Okay, let us go for similar figure. So take this any one of this similar figure is asking. So I'll go with one side. Angle should be something Equilateral triangle means all are 60 only, there is no doubt. And I'll go with one more equilateral triangle, 2, 2, 2. Angles are equal because your angle must be 60 degrees only in both the case. And I'll go with one more example. Take one small cube, small square and large square. I'll go with 1, 1, 1, 1 and go with 4, 4, 4, 4. Your wish. You can take the size, that is depends on you. You can take that. And we have to, okay, non-similar figures. Okay, you can take non-similar figures. Sorry, that is, I'll take trapezium one. Another one will be rectangle. You can take any shape. And second one, because angles are different here, it is 90. And second shape you can take any one. I want to differentiate, no? So non-similar figure. This is one in, this is triangle, and another one is rhombus. Both are different. This is three-sided and this is four-sided, no? So this is four-sided triangle. So this is the way we have to conclude. And the third one, state whether the following quadrilaterals are similar or not. No, they are not similar. Why? Why they are not similar means, okay, you can take the measurement, that is 1.5 by 3 is equals to 1.5 by 3 is equals to 1.5 by 3, that is equals to 1.5 by 3. Okay, sides are proportion, but what about angles? Angles are not equal here. So this is 90 degrees, all are 90 degrees here, but they are not equal. So see, what is our condition? If two polygons are said to be of similar, then angle should be equal. First of all, we have to go with angles. Angle should be equal. The first expression is only wrong, and the, okay, sides are proportionate, but this concept is wrong. So they are not right. This is 6.1. This is 6.1. We'll go for basic proportional theorem. Here in the exam, you may ask state and prove basic proportionality theorem. He won't give this definition, sorry, this statement. We have to write the statement. We have to write compulsory statement and we have to go for it. Now what is the statement? Let me see here. If a line is drawn parallel to one side of a triangle, first of all I want triangle. Go for triangle here. I'll take ABC. Right. If a line is drawn parallel to one side, I'll take this one side and I want to draw one line that is should be parallel to, assume that D is parallel to that of a triangle to intersect the other two sides. Yes, D is intersecting at D and this line intersecting at E. Okay, two sides in a distinct point. Okay, the other two sides are divided in the same ratio. That means the other two sides, for example, given that DE is parallel to BC, and we have to prove that AD by DB is equals to AE by EC. AD by DB is equals to AE by EC. No need to worry, the small technique here. Some construction is there. Instead of construction, just I want to go for here. Listen carefully. ADE, I want to take ADE two times, and with DM as a, here he has taken DM. That's why I'm taking the values M only. DM as altitude of triangle ABE, and this is also altitude of triangle ADE. So you can take EN. Now one time I'll take, see, if I take this triangle BDE and ADE, you can observe triangle. First of all, let me go with it. As a DM as, the area of triangle ADE, DM as a altitude. DM as a altitude, right? So DM as altitude. Now listen here carefully. This DM is a altitude of ADE as well as ADC also. ADC also, because we know that in previous classes already we know that the altitude can be inside of the triangle or outside of the triangle, right? So then let us assume that DM is a perpendicular, or what we can say, altitude of a triangle ADE or DEC. So now I'll go with that. So area of triangle ADE is equals to off into base into height. So this is height and base is AE. AE into height is DM. Consider one. Now in the same way, area of triangle, I'll go with the DEC. DEC. That is half into, what is the base? Base is EC into, this is DM. Consider equation number 2. Now find that triangle ADE by triangle ADC, area of the triangle. That is what we can write as 1 by 2 into AE into DM by 1 by 2 into EC into DM. I'm sorry to say that these two will get cancelled, then we'll have AE by EC. I'll go with the equation 3. Is there any doubt? You can check it out once again. Just pause the video and you can check it out. No problem. Then you can see. If you have a more clarity, if you want more clarity in other method also, comment in the comment section. We'll prepare one more. We'll go for one more video. Now this is one case. Now in the same case, we'll go for area of the triangle ADE as a EN as a altitude. As EN as altitude. EN as altitude. Area of triangle ADE is equals to half into base. You can observe base here. En is your altitude, means AD will be base. AD into En. So AD into En. Consider equation number 4. Now take, since this En is altitude for BDA also, then En is altitude, dB is your base. So that means area of triangle BDE, that is equals to half into dB into En. Consider 5. Solve 4 and 5. Area of triangle ADE by triangle BDE is equals to by this one. So get cancelled here. Directly can I do this and I'll go for this one. Otherwise I'll do this. Of AD and En by half into dB into En. These two get cancelled. These two get cancelled. Then area of triangle ADE by area of triangle BDE is equals to AD by dB. Equation number 6. Now you just observe these two triangles are DE and PE, DE and BC are both are parallel here. You can observe DE and BC both are parallel according to the given. So that means this BDE and DEC both are the two triangles and both are on the same base DE, and between the two parallel lines according to the previous learning. So we can say that triangle BDE is equals to triangle CDE. That means under this ADE, either BDA or DEC, whatever it may be, we can take that. That means area of triangle ADE by triangle BDE is equals to area of triangle ADE by area of triangle CDE. Both are equal. We can write in the place of this one, I wrote CDE. Now ADE by DB, how much we got? ADE by DEB, BDE, sorry, how much? AD by DB. So AD by DB is equals to AE by EC. Hence proved. This is a concept of that. You can observe here, same thing he discussed here. So in triangle ADE, En as a base. First of all, En as a altitude and AD. The same thing he has given. And the same one, BDE. En is a altitude. And when he gone for this division, then we got AD by DB. Same thing. And now assume that DM as DM as altitude and AE as a base. And for this triangle as DEC triangle also, we have same thing. So he followed the same thing and he equated. Now you can observe, note that the triangle BDE and DEC are on the same base DE, and between the parallel lines BC and DE. Yes, correct. Based on this, these two are correct. So from there we can conclude that AD by DB is equals to AE by EC. So this is the concept of basic proportionality theorem. And let us go for converse basic proportionality theorem. Converse basic. It is so easy, simple, and see, observe that. Take any triangle ABC and DEA. Now he has given that AD by DB is equals to AE by EC, and we have to prove that DE is parallel to BC. In previous case, now if in previous case we learned DE is parallel to BC, then we proved this one. Now in converse, if this is true, then we have to prove. So proof. Suppose that so since he has given that AD by DB is equals to AE by EC. Consider one, and the same way now you can observe. Suppose DE is not parallel to them. Suppose that DE dash is parallel to that. So if DE dash is parallel to BC, then we can write that AD by DB is equals to AE dash by E dash C. Consider equation number now. So observe these two, then what we get? AE by EC is equals to AE dash by E dash C. That means what you take anything, any point you can take, that it is equals to this ratio. That means AE by E dash AE by EC is equals to AE dash by E dash C. That means according to this concept, we should, that means E dash compulsory what coincide, compulsory coincide with E. Then I can write E is equals to E dash. Right. So therefore, whatever you can take any point on the side, that side AC, obviously that compulsory should coincide with the E. Right. So therefore, we can say that from this, if you take any line that compulsory parallel to, sorry, DE is equals to BC. Right. So this is the way we can, and from you can observe here, this is a concept till now we discussed. Now you can observe here, if a line AD is parallel to DE, so DE is parallel to BC, DE is parallel to BC, then we have to prove that this concept. That means till now what we learned, what we have learned, see AD by DB is equals to AE by EC. After this, in the future we can go for AD by DB, we just now we learn. Now AD by AB total we have to take, that is, and AE by AC, AE by AC. You can go for this again this condition, right, students? So next 6.2, 6.3 also we'll discuss, right? Thank you very much. Please subscribe.